So here's the quandary. I think everybody probably was sufficiently clever enough to divide 12 newtons by 4 kilograms and get 3 meters per second squared. Yeah? Right? I'm guessing also that for this guy here, if we solve this for S is going to be v squared minus u squared over 2a, right? So it's going to be 9 squared minus 6 squared. That thing divided by 2 times 3. And does that equal 7.5 meters? Yeah? Now what if we doubled the acceleration? What would happen to the distance? We cut it by a half, right? If we double this thing, if we made that like a 6, this would be what? I don't know. That's higher math. I can't divide that in half, but it would be half of that. Yeah? Right? It's Friday. I can't do it, right? Okay. Anyway, so we've got the distance here, right? Okay. And then when we calculate the work, I think you guys probably, if you had that number and you had that it was 12 newtons, you could have figured out that the work is force times distance. So 12 newtons times 7.5, right? That equals 90 joules. Yes? Joules? Are you picturing joules? Yes? Okay. Are we good? Right? Now, the second thing here, right, that was all sort of one thing. The second thing is part D, and it says, is this work the same as the increase in kinetic energy? Okay? Did anybody do that? Does that work out to be 90 as well? Yeah, that's kind of cool, right? So part D, we'll put D up here, right, is calculate the change in kinetic energy. So it's going to be 1/2 4 times 9 squared minus 1/2 4 times 6 squared, right? Well, if you do that, you get 90 joules as well. Is that a coincidence? Or is this something called the work energy theorem that says that if you do work on a system to give it energy, you can also, by the way, take energy away from something, right? But if you do work on a system to give it energy, then it gains energy by that same amount. Isn't that wild? There we go, right? Now, let's go to this last one here. Does the magnitude of the force change the result? If it always goes from 6 meters per second to 9 meters per second, does it change the result, do you think? Certainly it's not going to change this. Is it going to change this guy, though? Well, if it did, this would, by the way, disprove the work energy theorem, right? So I'm guessing that probably at the outset here we're not going to disprove that, right? We would all get a Nobel Prize simultaneously, right? Okay, but why is it not going to disprove that? Why is this always going to be 90? If I double 12, don't I double A? Yeah? And doesn't twice A make this half of 7.5? Yeah? And if you double this and cut this in half, what happens to the product? Same product, yeah? So whatever factor I increase this by, I decrease this by the same factor and vice versa. If I decrease this, I'll increase that. Isn't that wild? Yeah, and that's why it works, right? It's not some magical thing. It's just a shortcut way to accomplish the same thing that we've always been able to do. This is 3 steps. This is 1 step. Which do you like better?
1 step.
Yeah, 1 step's more fun, huh?
Oh, yeah.
There we go. And that's Cripple Creek.